Okay, we're looking at the second one here. The only difference between number 1 and number 2 is we have an angle of 20 degrees below the horizontal. So it says a 45 kilogram box is pushed across the floor. A factory to the right, which has a coefficient of friction mu, is 0.35. So that's helpful. That is M. The force used, we can call that applied force. And if you feel like, hey, I just want to go and solve my own rate, totally, if you feel like you can do that. The angle, although it's below the horizontal, we're still giving it the magnitude. It's 20 degrees. Every angle that I provide you, that's the angle you're going to be using in solving these. And we're trying to find what is the acceleration of the box. But we can be smart here. We could say that we don't know a of x, we don't know a of y, which would make it a lot more complicated. We'd have to do like system of equations and all that. But if we realize that if we set this up the right way, one of these is going to be 0. So, Thomas, how do I know which one is going to be 0?
Just look at the applied force.
Okay, I get the applied force here, but it's pushing down at an angle here. I guess, which way is this box moving? Horizontally. It's moving horizontally, which means we don't know what that is, but if it's moving completely horizontally, this means this is 0. Okay. Only if this thing was moving up or down would this could this have a chance of being a non-zero number. So we'll draw the free body diagram. We did this in a previous notes that I don't think have not been recorded, but f of g, f of n. Still moving to the right, so we have the force of friction. But in this case, our horizontal is there, and we are now pushing down. This would be like if somebody was coming in and pushing down on the box. It's not going through the floor. The floor is still here, but now the angle of this applied force is below the horizontal. Let me take a look at that. Yes?
How do you know whether to go down and to the right or right and down?
It doesn't matter. It actually doesn't matter. It doesn't matter if you... I typically like to go right and down because if I went down and to the right, it would get in the way of f of g here. Like I could make could make it this way red and then blue, but it might cover up f of g. So down and to the right is the same thing as right and down.
Wouldn't x become the opposite and y become adjacent? Does that make a difference?
Well, if we see here, this is what we have here. I can either do right and down, or in the other scenario here, there's a good question there, or we can go down and to the right. Sorry. We can either go right and then down, or we can go down and to the right. Those two blues would be exactly the same. They'd be both going to the right, and the red would both be going down.
When you do like cosine, wouldn't y become adjacent?
So there's another reason. Yeah. So yeah, good point. Let me bring up another sheet real here, real quick. So this is a good extension question here. We'll compare that to that. This is the angle we're given. That's the angle we're given. If you decide to go right, and this is actually why I do this way. I try to make the triangle around the angle that I'm given here. So I draw that so the angle's inside. If I did it over here where I did down and to the right this way, then you would have to figure out what that angle is right there. Now, you having to figure that out, you could do that, but that would mess up a whole lot of stuff there. Or rather than draw, that's a good point. Didn't think about it. Draw the triangle that makes the angle inside of that. Okay, so draw the triangles where Otherwise, you'd have to pick that. That's actually a way that I used to teach it, where you just pick whatever other angle. But that is so we're saying that this is the angle that is given right there. So I'm going to choose to draw that to the right and this down. I'm going to write the equation real quick, and I want you, for your homework, to finish it up here. We'll look at the differences, the f of x here. This is fa of x. And because that is connected to this angle, meaning it's touching it, that's going to get the cosine. And then this is fa of y, and it's not touching this, that's going to get the sine. So we talked about this before in another lecture. Fa of x minus force of friction, that the forces in the x direction are going to be exactly the same. If we compare the picture from number 1, the right and left direction are the same. Fa of x minus force of friction. Fa of x minus force of friction equals max. Whereas in the y direction here, this is the only thing that is different. Let's zoom down here. We have the normal force up minus f of ay down minus, last one, minus f of g here. We want to subtract everything that's down. Don't use parentheses. That can cause a lot of bad issues. Equals may. In this scenario, I'm going to wait just a few minutes before the bell rings. In this scenario, we will not have enough information here. We're trying to figure out what is a of x, but we also don't know the force of friction. This will be a problem where we will know enough over here where you can solve for the normal force. Yep. Plug it in there. We know that. Plug it in there. And then that will allow us to solve for a of x.